Hello.
Hey everyone. How's it going, Peter?
Good. How are you?
I am good. I'm glad because we've got this one tomorrow and then I am on vacation.
Oh, that's good. And you got coffee as well, right? Of course. You already muted yourself, so that's good. That's just telling me
Yeah.
that it's
I'm checked out.
stop talking at like
I got my yeah.
half on vacation already. But hey, Uni's back. Hey, Uni. Um, so yeah, part two today of this half Cilium week. I almost said mesh week. Cilium week. And today we'll talk about the network policy and observability. Um, oh, any plan for making a mock test? I don't know. I mean, I'll say definitely not in December. Let me put it this
No,
way.
we're all a little getting towards that point of I think it's time to pick out that PS5 or whatever gaming console or whatever you do and do it. But I think in the new year, I think it'd be a great idea because we also haven't seen the test. It's not available in the sense of us being able to buy it, right?
Yeah,
Or
it's.
even
I mean, it's not released yet, but we could come up with some.
yeah, flashcards or something like that.
Yeah, I mean, multiple choice questions maybe, or maybe some hands-on thing as well.
Mhm.
And I think everyone agrees that we should have Marino go through it, right?
Yeah,
Since you
absolutely.
already have the experience, I let me put it this way: I would feel more comfortable preparing that test than taking it.
Yeah. Yeah, it's a little bit of an interesting test. I mean, it's not really. So when I think about Cilium, it's a networking technology. You can use a lot of networking knowledge to get around it, but then you throw in eBPF and how it does the whole maps and all that stuff and event pickups and then it really changes your dynamic and how you think about how networking really has to be done. And then it becomes very specific and proprietary and then you get to this point where like okay now it's not really just general networking, it's actually very specific and dedicated to a specific technology area and
Yeah.
space.
I mean, let me put it this way: if we do create that, if we do like a mock test for Cilium, and if there are questions like that, remember, I will if I'm preparing the things, I will have to know the answer, and it will be on me to explain it, how it works. So we'll have it researched anyway, but definitely a good idea. We haven't planned for it, at least not in December, but it's something to talk about and think about in January. There's
I
also
agree.
Argo week. There you go. There's so many weeks that we could do. Uh, uh, yeah. Anyway, all right. So let's get started. I'll share my screen. There's going to be more demos today. I only have a couple of slides, but if there's questions, feel free to ask at any time. I'm just trying to find the correct window. Did I do window? Yeah, let's do this. This looks okay, right? Let's make it like this. All right, perfect. Um, all right, so today, network policy and then network observability. So these are the topics from the curriculum. So under network policy, you have to understand how the identity-based network security model works and what it is, policy structure, and then, of course, writing network policies, comparing Kubernetes network policies with Cilium network policies, and then as part of the observability, using Hubble from command line and UI. Um, I think um, I think Alessandro yesterday showed a little bit of a Hubble. I'll show more today. Kareem is asking for a direct link. So we have a link. Let me get you a YouTube link. If that's the link that you're asking for, you will be able you'll be able to see our comments and everything. Because for some reason you don't get comments on
Yeah, you have to go to the LinkedIn. I think it's in your stream specifically.
oh, wait, so I'll have to go. Actually, I can't. Even if I send a link to Kareem in the chat here, which is what I wanted to do. He's not going to receive it. So let me go.
Yeah. So that's,
Let me go to LinkedIn. Yeah. There you go. So you can also watch it on YouTube. There you go. All right. So hopefully this is the link. Kareem, if you were asking about a different link, let us know. All right. Yeah. So shorter than yesterday, I think, but more heavy on demos. So that's good. Okay. So identity-based security model. So traditionally, what was used as the basis for security and security enforcement were the IP address filters. So if we talk about like Kubernetes, we could say that pods would app sleep can send requests or initiate connections to the pods with label app HTTP bin. So what that would mean, if you wanted to do some enforcement around that, any node that would run pods with those labels would have to have that same IP filter installed. So the IP, we're going to go from the labels, and then we're going to actually track IPs and have an IP filter to allow or deny connections, right? Now, the problem is that when you're creating or deleting pods, you would have to go and update all these rules on every node, right, to add and remove the IP addresses. And the way of doing this, it's just not flexible, and it wouldn't scale, or it would scale very hard, right? So for that reason, what Cilium does is it separates the security aspect from the network addressing, right? So in Cilium, the security is based on an identity, and I think I mentioned this yesterday as well. So it's based on the identity of the pod, and that identity is derived from the labels that are set on that pod. So on the slide on the left portion of the image, I have labels for app version and environment. You could have more, you could have less. It's all up to you, right? But this combination of labels then creates or constitutes an identity that's called sleep, or I am calling it sleep. In reality, it's an ID, it's a number, and we'll see that in the demo. And then similarly goes for the HTTP bin identity, because it is a different set of labels. It will get a different identity, right? So green and red, right? Then what happens is on the right side, when a pod starts, so what's going to happen is that Cilium will check the key value store and try to determine which identity it needs to assign to the pod, right? So you don't have to track any IPs or nothing like that. What happens is that this key value store is queried for the actual identity based on those, based on the pod labels, right? All right, so the network policy. Network policy CRD ships with Kubernetes, but without an implementation. And what it does is it allows you to control traffic at L3 and L4. So you can use selector labels to select ports, and use ports to pods, and then use ports in network policies. There's no L7 support in the network policy, right? So you can't inspect the packets and use things like HTTP methods, headers, or paths, for example. Now, at a high level, looking at this resource, we can break it down into 3 parts: the pod selector and ingress and egress policies. So using the pod selector, we can select the pods in the namespace we want to apply the policies to. And then the security can then be enforced both at ingress and egress. So ingress is for packets reaching, right, the node, and egress is for packets leaving the node, right? So you can check. So for ingress, when the packets reach the cluster node, it is checked whether they can reach the intended endpoint. And then similarly for egress, each cluster node is going to verify outgoing packets to determine whether the packet can be sent to the destination. Also, if there's no policies created, so you just install, you have your cluster, you have Cilium, right? You don't have any policies. The default state is that all communication is allowed. However, as soon as you create your first policy or first rule, the enforcement will be automatically enabled, and then any communication between the entities would have to be explicitly allowed. So here's an example of, hopefully it's big enough to read, example of the network policy and those three different parts, right? So the selector, the part in red is telling us that the policies that we're going to define below will apply to any pods with the label role DB set in the default namespace, because that's where we're deploying the policy. One thing to note is that the pod selector is scoped to the namespace, basically to the namespace where this resource is deployed in. So if we would deploy a pod with the same role DB label into a different namespace, right, this policy is not going to apply, right, because it's scoped to the namespace. The first section of policies are the ingress policies, and these are telling us which entities can call into the pods that have the label role DB set. So if you look at it more closely, and if you try to translate what this policy is doing, so there's two high-level sections, if you look at it that way. One is the from field, and then the second one at the bottom, the last three lines, is the ports field. So the ports field, the ports section, will specify to which ports on the role DB pods is ingress allowed. So in our case, pods could call the role DB pod, entities can call the pods labeled with role DB labels on port 6379. Now, the from section is then specifying who can make the calls to the pod, or from where the requests can come from. And in this section, we have three different pieces: the IP block, the namespace selector, and the pod selector. Now, because all three are and items in the from field, the or semantic is going to be applied between them. So the IP block section is going to allow calls from that specific CIDR block, so all IPs from 172.17.0.0 to 172.70.255.255, except any IPs that fall under 1.0 and 1.255. And the second one, the namespace selector, is saying that the calls can be made from a namespace with the project label set to my project. And then finally, the pod selector is going to specify that calls can be made from pods with the label role set to front end. So the three conditions are ORed together, so the OR semantic applies. So as long as any of these three parts is true, the requests or the connection will be let through to the role DB pod. So as long as the caller satisfies one of these conditions, it will be let through. The last portion is the egress portion, and these egress policies will apply to calls that are made from the pods labeled with role DB. So notice there's the ports field, and this time the to field that specifies the destinations that the role DB pods can reach. So the port section is telling us that the role DB pods can reach destinations on port 5978, and the to section is telling us that the destinations that it can reach have the IP addresses between, in that CIDR block, 10.0.0.0.0 to 10.0.0.0.255. So it looks daunting to read, right? But if you like, whenever I see something like this, either be this policy or authorization policies in Istio, right? It's always easier to like actually sit down or write it down if you have to, right? And split it, like in your mind, make compartments about, oh, okay, so this is what's coming in, this is what can come out, this is what can go out, and these are the pods, or this is the set of pods that these rules apply to. And then you have to be careful with the or and semantics, right? Because that's always something that can come back and bite you very easily, because in YAML it's just that one dash, right? And you're already changing the semantics. All right, so what is missing in network policy API? So the one that I've already mentioned is the L3 and L4 support only. So there's no L7 support, so you can't use HTTP, you can't make decisions or policy enforcement on HTTP methods, paths, headers, and so on. It also doesn't do anything TLS related. So there's nothing like that. There's no node specific policies. You can't log any security events, right? So for example, when the connections are accepted or blocked, and you can't do any deny policies, right? You can only do explicit allow, right? And there's also more. There's a link at the bottom. It goes into more details on what's missing and or what's not implemented there yet. So what can Cilium do? What does Cilium bring to the table? So Cilium does implement the network policy CRD, right? So it does allow us to use all the L3 and all the L4 policies. And on top of that, it also adds two new CRDs. So there's the Cilium network policy, which is similar to the network policy resource or API, but it does provide more functionality. One of the big ones is the support for L7, support for HTTP. There's also support for gRPC and Kafka, right? So what happens is whenever Cilium detects an L7 policies, it's going to spin up an Envoy proxy inside the Cilium agent pod, and then that Envoy proxy that runs as a process in that pod that container, right, will go and enforce the L7 policies on that node. There's also, in addition to the Cilium network policy, there's also Cilium cluster-wide network policy resource. And the difference between the two is that the cluster-wide policy is going to apply the policies cluster-wide, and it will enable you to use node selectors, right? So you can create policies, but then also use node selectors to say this applies, like ingress from this node or egress to that node. You can use those. So a question, I guess a comment. So what comes in your mind when someone says layer 7? In my mind, it's API, load balancer, and web services. Yeah, I mean, the way that for me, I'm not from the networking background. Maybe Marino, once he comes back, he can chime in. He's more from the networking background. But for me, when I hear L7, the first thing that comes to mind for me is it's any HTTP. Like if I want to do I'm a practical person, right? So if I want to do routing on a specific header, that's L7, right? So anything HTTP concepts is L7. That's how I think about it. APIs, load balancer, yeah, I guess kind of makes sense, but I think load balancers are not L7 only, right?
Yeah, you can pick up network load balancers and even classic load balancers that just focus on TCP and UDP like connections and don't really look or inspect the HTTP header at all. And in those circumstances, even in the case of like Istio, like as a service mesh, it would use a layer 4 load balancer or a TCP-based load balancer instead of something like an ALB, only because you're able to configure some of those application features within a service mesh. But you can slice it up in any way you want. YZMon, I don't know how to pronounce your name. But yeah, when we're talking about layer 7, it's exactly like Peter said. We're thinking about a little bit higher level and more intelligence, more data, more attributes that we can work off of.
Yeah. So as you move up the stack, right, there's more metadata attached, more information, more context attached to everything. Oh, all right. So Cilium network policy. So let's look at this and see what are some of the features of the Cilium network policy. So the first difference between the network policy and the Cilium network policy is the selector part. So in Cilium, the selector is called an endpoint selector. However, you still use the match labels, and it isn't really different, right? Other than the name, it's just endpoints are Cilium concept, right? A concept that Cilium uses. However, on the ingress and egress portions, on those sides, there's a lot of extra functionality. So instead of having a single from section, there are 3 dedicated from sections that you can also combine together. So you have the from CIDR and from CIDR set. So the functionality here is equivalent to the from IP block section in the network policy. So you can specify the CIDR range and then optionally exclude any CIDR range like I had in that previous example. The from endpoints allow you to specify a match selector, and it's similar to the from pod selector option in the network policy. There's also a field called from requires, which allows you to define some base level requirements for the from endpoints conditions. From entities, this allow you to describe the entities that can access the endpoint. So there's multiple entities that Cilium defines. So entities such as world, cluster, host, remote node, ingress, and so on. So you can define rules based on like whether the packets are coming from the outside through ingress, from the cluster, from a remote node, and so on. Lastly, all of these options also have the 2 ports field that allows you to specify or select specific ports for the policy as well as the protocol. There's a question. Are these policies also implemented as eBPF programs? For L7 policies, how do they get around the performance of a single envoy, assuming there's substantial egress-ingress traffic? So for the first section, I think these policies are like enforced as part of the eBPF programs, of enforced or evaluated, if you wish, right? So if you have like an L4 policy, that's something that you can do at L4, something that you can do as part of the eBPF program. It knows how to do the comparison whether or decide whether a specific identity can access another identity based on some rules. And then it's going to drop the packets, right? And then for L7, how do they get around the performance of a single envoy? Yeah, so envoy, so you have 2 options, right? One option is you can, and I think that's the default one, envoy is going to spin up inside the Cilium agent pod. However, you also have an option to externalize that envoy and have an envoy running per node, right? I think it runs as a daemon set, I would say, right? Run one per node, just like the Cilium agent runs. Hopefully that explains answers the question. And then egress ingress traffic. Yeah, I'm thinking if there's for ingress, I don't know if Marina, you're going to cover ingress tomorrow or not. I'm not sure. Oh, you're muted.
Yep, I'll cover some of the
Okay.
ingress capabilities inside of when we discuss Cilium Service Mesh. Performance is something that's out of scope of the exam. Like
True,
there's
yeah.
a lot of testing that probably would need to go on, and I think I'd look more towards the open source side and seeing what Cilium OSS has been doing from a performance standpoint versus this exam.
Yes, yeah, but I think I looked at this yesterday as well. Yeah, so there's a way either run it inside at least for east-west traffic, right? Run it inside the Cilium agent, or you can externalize that Envoy and run it outside, so you can scale it independently if you need to. Okay, going back to so we did the ingress. So the egress side, similar fields, similar settings that you can configure. You have the two-sider set and two endpoints and two entities. There's also two new fields that are called two fully qualified domain names and two services. So the first one is I guess self-explanatory, right? It allows you to specify a fully qualified domain name. So you can say hello.com, and then you can do matching and policies based on that. And the two services one is similar, but it's for Kubernetes services. So you can use that to target a service based on its name or using label selectors. There are also deny policies that look more or less the same as ingress, but instead of writing allow policy, they allow you to write deny policies. There are a couple of unsupported things with the deny policy specifically. So you can write L7 deny policies. Deny like URLs are used to fully qualified domain names to deny traffic to domain names. All right, so another one can also be implemented to protect the host. And will this be by any chance break the traffic that goes to the API server and thus causing damage to the full?
Yeah, so what it is like the control plane. I mean, is the policy that you implement going to affect the control plane activities within Kubernetes? And in actuality, no, it actually won't. You're supposed to exclude it altogether. And I think there is a practice for doing so within the Cilium documentation. But to answer your question, Kareem, the answer is no.
All right, I have a link here that I want to show, but I'll show it when I go to the demos. So I don't do like too much switching back and forth. I only have a couple of more slides left, so we'll do that. Okay, so L7 stuff. How can you do that? So Cilium, as I mentioned, uses Envoy to enforce any L7 policies. So whenever you create a policy that uses L7, right, Cilium will go and start an instance of Envoy. And then that instance of the proxy will be responsible for handling all L7 requests for that node. And I also mentioned there's a way to run the Envoy proxy outside of the Cilium agent. So here's just an example. It looks exactly the same. The rules section has the HTTP field where you can then specify things like methods, paths, or headers. So what this one does is the policy is written for any apps or any workloads or endpoints, I guess, with label app hello world. And it's saying that those pods can receive traffic or packets on port 80. And the only methods that are allowed are get on /API and put on /version path when x-sum-header is set to true. So you write these things in the same way. You're just using the HTTP. You're just specifying the HTTP rules there. So you can match on path, method, host, headers, right? Yeah, and you can do it for both ingress and egress sections. So the last thing that is also mentioned in the exam, I'll mention it's explicitly called out in the curriculum. It's layer 7 protocol visibility. So by default, you only get visibility in L3 and L4 packet events. All right. You do get visibility into L7 if you configure an L7 policy. However, there's a way for you to get L7 visibility even without enforcing any policies, right? So you don't have to create an L7 policy. And then you can use an annotation. It's a specific annotation. And I notice I only put the the value of the annotation, not the actual like name of the annotation. I'll fix that. But you basically say which traffic direction, which L4 port, L4 protocol, and then L7 protocol you want to enable visibility into. So you could say like egress, UDP, 80, whatever TCP, right? And then what's going to happen is that when Cilium sees that, it's going to transparently redirect traffic to the Envoy proxy, right? So you have to have that Envoy proxy running in the Cilium agent, right? So there's a way for you to get L7 visibility as well, but you don't have to go and just create a dummy policy just so you can get the visibility into it. And then lastly, the cluster-wide network policy. Functionally, as I said, same thing as the Cilium network policy. You can specify the same ingress and egress policies and rules. However, instead of applying the policies at the namespace level, cluster-wide network policy allows you to apply the policies at the cluster level, so you can encompass and or include one or more nodes, and it also allows you to use a node selector, which is similar to the endpoint selector. However, you can only use one at the same time. All right, so I'll go into demo. And this is a great time for anyone to ask questions. Just stop presenting and should be able to switch soon. Go. My terminal. Yeah, I'll make. Hope the size is good enough, right?
You might want to make it a little bit bigger.
A little bit bigger.
Yep.
Is this better?
It's shrinking the size of the console, but it's not making the font bigger. I'm wondering if you type
Oh,
into
that's
the window.
weird. It is. Oh, let me re.
There we go. Ah, okay, that's better. That's
yeah,
better.
I think it's the.
Okay.
Oh, that's weird. Yeah, let me see if I can. Yeah, if I don't I have to resize. I have to make the. Is this good?
Yeah, that's perfect.
Yeah, I have to make the fonts bigger, but then also resize the screen so it, I guess.
Yeah, the shared screen, right? Okay. Yeah.
Resets it or something. I don't know, but
yeah.
All right, so I don't have anything installed yet. I will. I have the. I'm going to be using Kind. So this is the configuration for the Kind cluster that I'll be using. I'll have 3 nodes. I am disabling the default CNI because we're going to install Cilium, and Cilium is going to be our CNI. So let's do that. Kind create cluster. This might take a couple of seconds. I wanted to say Marino can tell a joke, but I don't know. I don't know how.
We're not doing that again. We tried that very yesterday, did we not? And
no, we didn't. No, it was last week, right?
Yeah.
There was a joke, but
yeah, that's right.
There were also crickets. So at least crickets from my side. I don't know. Maybe there was someone laughing on the other side. I'm just giving Marino a hard time. All right, so look at that. The cluster is created. All right, so we have the cluster. So I can just check the nodes. Right, we have 3 of them. Notice the status is not ready, right? Because we right, we don't know, we don't have IP addresses, right? We don't have the CNI. So what I'll do next is, and this will be a long command, but I'll explain as I go through it. I could format it better, but I'm sorry. So I'm using Helm to install Cilium. We're going to install version 1.14.4. We're going to install it into the Cube system namespace. We're setting the Cube proxy replacement to strict. We're setting the service host to the kind control plane and then the port. So this is so it knows who to communicate with. And then all the other settings here are Cilium specific. So we're enabling Hubble. We're enabling Hubble UI. We're enabling down here Hubble Relay. I'm also installing Prometheus and enabling it. And I'm also specifying or enabling open metrics, setting it to true, and then specifying which metrics we want to enable. Because by installing this, enabling Prometheus, I'll also install Grafana later. So we'll be able to use Grafana to actually look at the dashboards and the traffic there. So this is just specifying which metrics should be enabled and configured. So by the way, all of this, I didn't came up with this from like top of my mind. This is all in the documentation, of course. So let's do this. This was fast. And then separately, I've already have it installed. I've installed Cilium CLI. I have it installed. Again, this is all from the Cilium docs, cilium.io. So let's run Cilium status just to see how we're progressing. So there's some errors. I hope these errors will go away, and they're only here because the pods are not started yet. But I sincerely hope that's the case. I think it is. Let's take a look. Yeah, so the containers are still being created, some of them. So should be a couple of more seconds and we'll be up and running soon. There you go. We're all green. That's what you want to see. Cilium is okay. Operator is okay. I don't have the daemon set envoy. So this is that thing when I said embedded mode is running Envoy as part of the Cilium agent, but you could have it separately and run Envoy as a daemon set. So this is disabled. We disabled cluster mesh. I mean, it's not enabled by default. And then the status of all the deployments and all the image versions that we have running. All right, so let's do, I'll deploy HTTP bin just as our sample application. Go, so should be up soon. And then just a little bit, one thing that's kind of, I get the idea, but it's kind of confusing, was confusing at the beginning is, so there's the Cilium CLI, right, that you run from from your terminal, if you wish, right? But there's also a Cilium CLI inside of each cluster agent that has different functionality. So this was kind of it would be nice if there was one CLI, let me put it that way, right? But so let's do, I wanted to do, let's take a look where this pod is running. So it's on worker node 2. So if you look at the pods and the cube system, so what I'm trying to do is go to this Cilium agent. So we'll exec into this one in the cube system, and then we'll do bin bash, I guess, right? There you go. So now we're inside of the Cilium agent that runs on kind worker node 2. So from here, we have access to a Cilium CLI. Oh, there's someone saying that is changed now to Cilium Debug. The CLI inside the pod has a new name now. Oh, okay. I wasn't aware of that. So it's a Cilium Debug. Is there is that a separate CLI that you install? Interesting. I haven't
encountered a separate CLI for Cilium Debug, but let me look into it.
I'm trying to. Yeah. Anyway, that's interesting. I didn't know about that, but basically from the Cilium CLI, I'm going to be calling it Cilium CLI in the Cilium agent. You get access to way more like commands that you can go and run. So one would be, let's say, Cilium identity T and then list. So we can list all the identities that are that Cilium knows about. So you'll notice there's put it this way. So there's an identity here for our HTTP bin app, right? So the identity has a number 2588, and then these are the labels, right? That Cilium uses to create that identity. So it uses the app, the namespace name, the cluster name, right? The service account name, and then the version, right? And it does that for others as well. All right, so let's actually, well, let me exit here. I'm not going to complicate with multiple terminal windows yet. So next thing, we'll do the monitoring example. I'm just running this from their example folder. So this will configure Grafana, and then it's going to actually go and deploy Grafana in Prometheus. So if you look at that in the Cilium monitoring, we have Grafana and Prometheus up and running. All right, so we have HTTP bin. It's there. Let's also deploy sleep. Go, and let's wait for this one to come up. And now if I try to send a request from IT deploy sleep, I try to curl to HTTP bin, 8,000 headers. Hopefully sleep is up. Yeah, there you go. I get back the response, right, from the sleep. So this is all expected, right? We haven't applied anything. We haven't done anything yet. So what I'll do next is I will create a default deny all ingress policy, network policy. So let's do that. So this is how it looks like. So we're setting the pod selector to empty, and then just saying policy type, we're creating an ingress policy type. So once we have that, if I repeat that same request, it's not going to work. It will eventually time out. But what we could do is we could use Hubble. So I'll do the Hubble CLI, and it will say Hubble, right? Hubble, oops. Hubble, observe, and then we can specify the requests to the default namespace, right? Oh, I have to do the port forward. Hubble port forward. Let's do that. Told you there's going to be a lot of windows open here. So down here, and then let me make this smaller. There you go. And now we'll do Hubble observe. Observe to namespace, to default namespace, and then follow. Okay, and now I'll repeat the request. So now I should see. There you go. So now we can get the network flows. You notice that it's getting denied, right? Ingress denied, because we have the deny all ingress policy. There's also a UI version. Let me just see. Let me see. Let's do the UI version as well. And I'll have to so So Cilium Hubble UI, right? Let's do this. There we go. Oh, now I have to reshare my screen. Just give me a second. I'll do that. So I'll share the whole screen. Entire screen. This one, I think this might be, well, we'll see. How is this readable or not readable? It's good. I'm assuming it's all right that people can see it. So
yeah, I can see it. And what's really nice is like, so this kind of resembles, or it's starting to resemble, another tool that I'm also familiar with called Kiali in some ways.
Yes, yeah. However, Kiali has more. It looks like a one portion of Kiali where it shows you the service map, right, and the flows and like what happens. Like these are the ones that I did initially, right, and it was all good. It got the packets were forwarded, but then all of these here were dropped, right, because of that policy that we apply. Yeah. So now if I another thing that I wanted to show is from the CLI here. So I stop the UI and then we'll come back to UI. So what I could also do is Hubble observe, like from the CLI, you can do way more observe. So you can do JSON if you want, right? You can get the output in the JSON and it's going to give you more information, or I guess maybe more readable information. But then you can also be more specific and say, well, I want to see everything from like that was coming from the app label sleep and everything that was going to label, right? HTTP bin, which is everything that we did, right? But and then you can also do, I think, verdict dropped, is it? Yeah, there you go. And then you can also get like all the denied or dropped, right? Flows that happen. So it just gives you a way to filter these flows or look at these flows from the CLI as well. Like same thing here, right? And then you get the same thing in the UI. If you would click on it, you would get all the details there as well in the flow details. All right, so we showed the UI. So what we'll do next is, so let me clear the screen here, put this in the middle. I apologize for moving things around. So I'll modify the network policy to allow connections from sleep to HTTP bin. So let's do that. So this is how this would look like. So we're applying this policy to HTTP bin. It's an ingress policy, and it's saying, well, allow ingress from any pods with the app sleep label. If we do that, and if we repeat the request, this starts working again, right? And then Hubble UI, Cilium, Hubble UI. If we restart this guy here, we should start seeing all green again. Fault. There you go. Less than 20 seconds ago, right? So this is, it's working again, right? So we enabled everything, and then we explicitly disabled, we disabled everything, all ingress, and then explicitly enabled the thing. So just to confirm, DNS request response to Kubernetes DNS will continue to work, and that should be visible in Hubble. So you will have to, let me see. I think there is a way for, you will have to use explicitly select kubedns as a pod selector, right? When you're writing to explicitly allow DNS ingress. That's what I'm trying to say. And I think that will be visible in the pods, in the flows. But we'll take a look. I have the egress policy demo that I'll get to, and we can see it there then. All right, so we enabled this. So the next thing that I'll do is I will create a namespace, another namespace, sleep namespace, and deploy another sleep workload in there. So we have two sleep workloads. One is in the default namespace, and then another one is in the sleep namespace. So if we send the request from the sleep namespace to, we have to do the namespace now. This will fail, right? Because we have that, see, it's dropped. We have that deny all ingress policy. However, we could use a namespace selector. So allowing ingress from the sleep namespace specifically. So on the app, applying this for the HTTP bin, and then saying we're allowing ingress from a namespace with this name. So if we do that, and then if we repeat from the namespace, this should work again, right? And then this one should work because we haven't changed anything, right? So both of them will work. Now, the only thing here is that the policy is not restrictive enough. The one that this one here, because it's basically allowing any pod, right, from this namespace to make calls. So what we could do is we could combine the namespace selector with the pod selector and be very explicit in our policy. So this is how this would look like. So this is the same here. We're saying we're allowing connections from the sleep namespace, but only from the pods from the sleep namespace with the app sleep sleep label set, right? So this is just narrowing it down. So this will all still work, right? Because I don't have anything else deployed there, right? But if you would deploy something else to the sleep namespace, it would not work, right? Because we're being very explicit in what we're allowing. All right, so let's clean this up, and we'll do another one. So instead of denying, right, all ingress traffic within a namespace, what we could do is we could have a policy that automatically allows traffic within a namespace, but then denies traffic, all traffic from the other namespaces, right? So that might be another way to do the isolation, right? If you wanted to do it per namespace. So this is how that policy would look like. So we have the policy that allows requests from within the same namespace, right? So this will continue to work. Previously, when we did the ingress only, right, or all ingress, it didn't work. And then this will automatically then fail, right? So this might be a better starting point for you to just use, oops, I cancel this out. Trying to scroll here. Where is it? To use a policy like this that says only allow communication within the namespace, right? And then you could deploy this to all the namespaces that you have in your cluster. So you know that at least you get the isolation on the namespace level, and then you can go and poke holes where needed if you want to do across namespace communication, right? So the tool that I wanted to mention earlier is the editor. So it's editor.networkpolicy.io. So this one, I don't know if it's fully up to date or not, but this one also gives you a way to, I guess, explore all the different ways and combinations on how you could create the policies, right? So you could say, oh, I'm just going to allow from any endpoint to port, and it is going to go and generate like an ingress section. or you can say allow to any pod, right? And then allow the ingress here, and then Kareem explicitly allow the kube DNS. This is how you would do it, right?
What about a default denial? What would that look like? And also, could you maximize or increases the font or something? It's a little tiny.
Oh, like the the font on this one, you mean?
Yeah, exactly. Or yeah, that looks better actually.
Is it? Let me see if I can.
But I'm curious what it would output as a default denial.
So if you go default denial, you just remove all the
nice.
egress
Wow, okay.
rules, right?
I like that. Okay.
Yeah, and then if you do a default deny on ingress, it's that's the one that I started with, right?
Yeah.
In the demo. But yeah, it's pretty nice. You can click through and see like different, see the different options you have, right? And check how that looks like. All right, so let's do a policy that denies all egress traffic from the sleep pod. So let's apply that one. So deny sleep egress, applying to app, and we're just saying policy type egress. So if we try to do from the default namespace, right? I'll just remove it. This is not going to work because we're saying nothing from sleep can go out, right? We're explicitly denying that. But the error is could not resolve host. So it's not the, remember previously when things were actually being denied, it was waiting for it to time out, I guess. But this time it's actually saying that it cannot resolve HTTP bin.default, right? Which is a different error. So what we could do is, so let's update the policy a little bit and say, well, let's allow egress to app HTTP bin, right? So now we're, oops. However, it's still the same, right? And the reason here is the DNS, right? So we're denying all egress traffic, so all outgoing traffic from the sleep pod. And this also includes the request to resolve the HTTP bin DNS name, right? So if I would do something like, let me just see. So I would, get service. If I would get the IP, and then if we would do something like this, this works, right? So if I do IP, so it's not the policy that's preventing this per se. It's the DNS, right? So we have to explicitly allow the egress, allow egress to the kube DNS. So we can do that with a separate policy. Just call it allow DNS egress policy, egress to the kube system namespace to the kube DNS pod. So we do that. Now we should be able to make a request to HTTP bin.default, and this is now going to work. Yeah. So the question that Kareem had.
Yeah,
go ahead.
I was gonna just say, right, like, so even to Kareem's point, we broke DNS connectivity, which is entirely true. But in your situation, like what you actually used was you used the label directly towards kube DNS. Another way you could do this without actually doing the kube DNS is actually blocking port 53 or any sort of communications to that TCP port or UDP port 53, and that would effectively provide the same level of functionality if we were trying to block DNS requests.
Oh, if you were trying to block it, yeah. All right, so let's show what are we on time? Almost up on coming up to an hour. So L7. So let's do L7, and I have Prometheus, I have Grafana. So what I'll do is, let me see. I'm gonna need more windows, so I'll switch to a different one. So what I'll do here is I'll just start making requests, and I'll copy these commands because I have them. So I'm going to be sending a request to HTTP bin default post. And then I'll be sending requests to headers. Wait. Oh, it is running. Okay. And then I'll be sending the request to, I'll be just sending a bunch of requests. So I'll keep that running. We're not going to have to look at that. And we'll go back to this one. So let's say that we're trying to only allow traffic to the /headers path and only for GET requests, right, on to the HTTP bin, right? So we can't use network policy because network policy doesn't support L7. We'll have to use the Cilium network policy. So let's do the send a request first. So we'll do curl. We'll do post to HTTP bin default port 8000 post. This works, right? And then if we do IP, oh, it's not post. This one is get. This one works as well, right? So let's create a policy. That's going to look like this. Oops. So for this one, from the sleep, 2 ports, and then the rules is get and headers. So let's deploy this one. So now the post request, where is it? This one should fail, saying access denied, but the, oh, wait. So let's look at it. I think I missed something. Oh, it's 8000, right? It's not 8080. I think that's the issue. That one should not be failing. Okay, so let's try again. So let's do, so this one should work, right? But it's not. What did we miss, Marino?
What does your policy look like?
Yeah, let me, let's take a look.
Because you're in the default namespace. 2 ports, 8000 method get headers. What was your request path again?
So it's
curl headers 8000
right.
HTTP bin default. Could you explicitly use the get method in as a request?
I can try, unless it's, let me just try one thing.
App sleep, hold on, ingress from 2 ports. Deploy sleep.
Let me just try one thing. I think I know what it is. No? Thought it was a, what am I, we're missing something. Oh, let's see. I deleted all the network policies.
Oh, hold on. 1 second. It says ports 80.
Yeah. I wanted to. Yeah. So let's deploy it again. So I'll redeploy it. I'll redeploy the 8000, right?
Mm-hmm.
All right. So endpoint selector. So HTTP bin, ingress from endpoints from sleep, right?
Yes.
To the 8000. And rules is HTTP method is get and path is headers. So it should allow this one, right?
So the source is from sleep, the sleep pod. The destination is towards the HTTP bin on port 8000 with the path, with the path headers and the method get. Yeah, that should be.
Looks good.
Oh, hold on a second.
What
protocol. Why shouldn't it be HTTP? Or maybe I'm confusing that with.
Well, we have the thing here, so let's try it. Right?
Yeah.
Let's see if this works. All right.
Yeah, go ahead.
Oh no, go ahead.
I was just going to say, can we take the policy and then have it tell us what it's doing, or do we have to go the other way?
I don't think it does that.
Okay.
I don't think it does that. Yeah. So we're saying ingress traffic from. So we're allowing from any endpoint to port 8000, right? Actually, this one doesn't support. Oh, wait, it's not. And this is outside of the cluster, so we don't want service, right? It's in namespace, right? Allow from pod selector, right? App sleep, right?
Mm-hmm. From pod selector match labels app sleep ports 8000. But is that the source port?
Oh, yeah. That's what's odd. Wait. No, the pod selector should be. Oh man, we're getting. All right, so policy namespace app HTTP bin, right? Oops.
And not to scare anyone, you don't have to deal with this on the exam itself. Like it's multiple choice.
Yeah. At least
It's
you
good.
yeah, exactly.
Yeah.
And then this one doesn't. Oh, this one doesn't do the. What is it? The HTTP policies. It doesn't do those. All right. Well, if nothing else, I don't know why this. What did I mess up? Because I went through this yesterday and it was working fine. So let me see.
Can you show me all your policies that are applied right now, or all the ones that
I
you
don't
have?
have. I don't have any. So let me just let me just try again.
Get Cilium net policy.
So 8,000. This one should work, but it's not. Wait. So let's do. But it's not that, right? No.
It's not DNS. No.
No, it's not that. That's what I wanted to check. So these are all the policies that I have. That's the only one. Now everything's deleted. Now if we try this
That
works,
yeah.
right?
So let's go back and look at that policy for a second. The one that
works as well. Yeah. So this is the policy. There you go.
Okay. So we're matching on HTTP bin, which is correct. That's the destination we're trying to go to.
What am I missing?
I think it's just the ordering of the two ports. I don't think that should be there because it's all under. I don't know. Okay, so it's from the sleep pod. Going to port 8000 protocol TCP rules HTTP method get headers and Cilium Envoy is supposed to be processing this rule or policing or enforcing this rule.
Yes.
The policy looks good. Like that's the thing that bothers me. Like what's wrong with the policy here? Nothing.
Let's look at, I'm just trying to find an example and we'll look at the examples. Let's move this here so everyone can see. So we'll do, I think there's a specific section where they have the L7 examples. Is it layer 3 and there's layer 7 somewhere, right? And let's see what we're missing, right? All right. Well, we could do services based if you want to, but I'm curious why this wouldn't work now. So let's see, layer 4, layer 7. There you go. Okay. So union. Okay. Let's do it this way. Oh, I can figure it. Oops.
Yeah, this is. I'm looking at an example as simple as it possibly can get.
There you go. There's an
same one. Yeah,
there's exact one, right? So allow HTTP get /public from this guy to app service. So allow get /headers to port 8000, right?
Maybe you're
from sleep to HTTP bin. But let's see
Yeah.
if I'm missing.
The only thing you're missing are quotes. So
that's what I see as well. But I wouldn't think that's the problem. But let's double check, right? We'll see. Let's do the quoted one, and I'm just trying to make sure that I'm not missing like a dash or it's indentation somewhere or something like that.
No, it all lines up pretty
right. It
good.
lines up well.
Yeah.
Uh,
That's why I was like looking at the policy, and it looks like exactly the same.
2 endpoints with a but request to request on ports other than. Okay, so the other thing that I'll try. So let's do that. Let's do this. Okay, so now it's in the quotes.
No,
The
that didn't
post,
help.
which is fine, right? This should fail because we're
Yeah.
only explicitly allowing this.
Get.
But this one doesn't work either. So let me try. I wonder if it's ports thing that's messing it up for some reason, but
Silly one maybe labels. No, labels look to be okay.
no, see, this is odd as well. This doesn't work either.
Can you just verify the labels on the workloads? Like get pod show labels.
Yeah. App HTTP bin, app sleep.
App
sleep, app HTTP bin, right?
Yeah.
All right. Well,
it is. I know it's supposed to work. So, I mean, you could trust Peter and believe us that it works.
I don't know. I mean, we tried port 8000. I also tried let's just do this. This. Where is it? Oh, I know what it is. Let's see if it's this one. I'm so embarrassed now. If it's
Do you think it's the container port issue? Like it's because we use the container port 8080 versus the.
There you go. All right, so it has to be the container port.
That's interesting. Why the container port though?
Because that's the endpoint. It's not the service, right?
Oh yeah, it's not the service endpoint.
So if we would use to service, then we could probably, assuming service allows.
That's the distinction. Yeah, because we were going directly to the actual pod.
All right, there you go. I'm glad this wasn't an exam. Yeah, so the post doesn't work, right?
But the get does.
The get one will work. Get on headers will work. The get on IP is not going to work either, right? Because we. Yeah. All right, and now I can finish the demo, right?
Yeah, there you go.
Yeah, so let's sorry everyone for going through this, but okay, so we said cube system. I just want to see what the it was on kind worker 2, right? So it was on this one. I just want to show list the processes. Notice there's a Cilium envoy. It's running inside the Cilium pod, or the Cilium agent container, rather, right? And then last thing, I just want to show the monitoring. And this was literally the last thing that I had, there we go. So if we go to L7 metrics, we're still seeing a bunch of metrics because remember, I'm still running these commands here. So you can see if you've done if you're familiar with Istio, maybe, right, you're familiar with these with Grafana at least a little bit, right? But there's also metrics for like Hubble if you want to look at I guess control plane metrics if you want to call them that. Cilium metrics in general, right? CPU usage, the memory status, the latency, etc. And then the last one is the operator, right? But the idea here was to enable L7 metrics, right, for the workload. And you notice we have 403s and we have 200s as well, because we have that policy enabled, right? All right, so yeah, I think it went well if we forget the last 15 minutes.
No, that's actually really good.
to
I mean,
figure
I,
out
I
the-
personally think I personally think like being able to go through an exercise like that, seeing the distinction of using the service-based policy versus the actual like
yeah,
endpoint policy,
yeah.
that's
And
valuable.
it's
Yeah.
like throughout my career, whenever there was I would call this like a stupid issue, like a silly issue. It was
Yeah.
always something very simple and something. So it was never anything elaborate, It was
Yeah.
always some
But
business
if
thing.
you actually think about that, I wouldn't be surprised if that something like that showed up on the exam. Like this wasn't even intentional. We just literally
That's
like
a good
thought,
point. Yeah. You're
right?
completely right. Yeah, there could be uh
That
here's
slight distinction. Yeah.
here's how the service looks like, here's how the pod looks like, here's the policy, it's
Yeah.
not working, what's wrong, right?
Exactly. So, not that they're trying to overly trip you up, but it's, we're talking about an exam where you really got to know how Cilium works and you got to be applying the right policies at the right time.
Yeah,
So,
yeah, yeah. All right. Well, thanks, Marino. Thanks
no,
everyone
thank you.
for sticking with us and asking questions. We are back tomorrow, right? The last day tomorrow. And Marino, what are you going to talk about tomorrow?
Yeah, so we're going to dig into some of the other deeper advanced concepts around Cilium. So BGP networking and how we start interfacing with external networks and external workloads, as well as digging into something called cluster mesh. So understanding how we would achieve connectivity between multiple clusters running Cilium in the sense of wanting to be able to have a path for our pods to be able to communicate across. So we're actually going to dive back into like technologies around VXLAN and Geneve and how those come into play. And then the other one is Cilium Service Mesh. So we'll dig into how Cilium Service Mesh works with Ingress, with the Gateway API spec, works with mutual authentication and how they achieve MTLS or mutual TLS. And then we'll also understand some other elements of how the service mesh functions within Cilium as well. So really looking forward to that. That's our last stream, and that should round out everything we need to cover for the Cilium Certified Associate. So really looking forward to it. Peter, I'm excited for tomorrow, and I'm actually excited for my time off right after that.
I'm excited for tomorrow as well because it's going to be all you and
Yeah,
Alessandro
right.
tomorrow, so it's not going to
Yeah,
be me. So we're both
yeah, yeah,
excited, and
yeah,
hope everyone to see you
yeah.
here tomorrow as well. And then thanks for joining today, and we'll see you all tomorrow.
Take care,
Bye.
everyone.
Yeah, bye.